In problem number 12, we are asked to find the point of diminishing returns. We are given the function v of x, where x is the amount spent in a particular month on advertising in tens of thousands of dollars, and v of x is the volume of sales. In other words, it's the number of vehicles sold during that month. We're given the equation for the function v of x, and we are asked to find the point of diminishing returns. So let me first explain what the point of diminishing returns is, and then we will go ahead and find that point. Point of diminishing returns is a kind of inflection point. So suppose we want to graph the relationship between the amount spent on advertising x and the volume of sales v. If x equals to 0, if nothing is spent on advertising, there will still be some cars sold, and so our plot will begin somewhere above the origin on the v-axis. As x is increased from 0 into some positive values, in other words, if some funds are being now spent on advertising, we can expect that to have a positive effect on the volume of sales. In other words, we will observe an increase in sales. And initially, as x is being increased from 0, as x is being increased, the volume sales are likely to increase at a faster and faster rate. And so that basically means that the graph, not only it goes up, but it actually is becoming steeper and steeper and steeper. And so the effect of additional dollars spent on advertising initially leads to more and more a faster and faster increase in sales. This will continue up to a certain point, and that point is the point of diminishing returns, where the behavior of the function will change. As x is being increased past this point, the volume of sales will continue to increase, but the rate at which the increase will begin to decline. And so the graph will begin to bend the other way. Initially, the graph is concave up. Actually, let me make this remark here. So initially, the first segment of our graph right here is concave up. And then the second segment of this graph is concave down. The point where the change occurs is the point of diminishing returns. So the words diminishing returns refers not to the fact that the sales will begin to decline at that point, but rather they refer to the fact that the rate at which the sales grow will begin to decline at that point. Now, since we see that the point of diminishing returns is an inflection point, we will be looking for it using the second derivative. At an inflection point, the second derivative of the function must equal to 0. And so we will calculate the second derivative of our function. We will then set it equal to 0 and proceed from there. First, we need to calculate the first derivative, and we differentiate term by term using the power rule. So we get negative 0.1 times 3x squared. Then we have plus 2.19 times 2x. And then plus 1.2. The derivative of the constant term 15 is 0 because it's a constant term. It does not change. Its rate of change is 0. Let me simplify this first derivative. It's negative 0.3 x squared plus 4.38x plus 1.2. Okay, now next calculate the derivative one more time. We take the derivative of the derivative, and that gives us 0.3 times 2x plus 4.38. Now set this equal to 0 and solve for x. I lost the negative sign in front of the first term. And so we get negative 0.6 x plus 4.38 equals 0. This equation is fairly easy to solve for x. 0.6x equals 4.38, and so x will equal 4.38 divided by 0.6. In other words, 43.8 divided by 6. 42 divided by 6 is 7, and then 1.8 divided by 6 is 0.3. And so we find that the point where the second derivative is equal to 0 is 7.3. We only found one point like that. At all other points, the second derivative of this function is not equal to 0. Now, in order to ascertain that this point is indeed an inflection point, we need to make sure that a couple of things happen. So first of all, the second derivative has to change sign at this point from positive values to negative values. And also the first derivative of the function has to be positive at this point so that we are actually seeing the growth in sales. Both of these are fairly simple. If you draw the number line and mark this point on the number line, 7.3, let's say this is x. We have our formula for the second derivative, namely is right here. Negative 0.6x plus 4.38. Let's select our test points on the two intervals of the number line to the left of 7.3 and to the right of 7.3. So for instance, we could use 0 as a test point on the first interval, and then we can use maybe 10 as our test point on the second interval. And so if you plug in 0 into negative 0.6 times x plus 4.38, the value that comes out is 4.38, and that is a positive value. So our second derivative, sorry, I should use v, not f. Second derivative of v is positive at 0, and therefore it will be positive elsewhere on that first segment. It is negative at 10 because you're going to get negative 6 plus 4.38, and that's negative, so negative here. And that confirms that at 7.3 we have a sign change from plus to minus, and the function goes from being concave up to being concave down. Emphasize this a little bit more. Okay, the fact that the function is increasing is easy to confirm. Simply plug in the value of x equals to 7.3 into the first derivative and see that that is a positive value. I will not do this calculation here, but I'll just write perhaps here that that is another thing that we need to check. The value of the first derivative at 7.3 is positive, and that is indeed the case. So our answer is that the point of diminishing returns is x equals to 7.3. Let's take a look at the question again that the problem is asking. It's asking to find the point of diminishing returns, and you see that the answer choices are in dollar amounts. Now in the problem it says that x is the amount spent on advertising in tenth of thousands of dollars. So the dollar amount corresponding to x equals to 7.3 is 7.3 times 10,000 of dollars, and that's going to be $73,000. And so therefore the correct answer choice is the one with the $73,000.